Hi, so it's Kelly Shanahan on the board of directors of Metaviver, and I am here with Dr. Dihua Yu of MD Anderson Cancer Center. Dr. Yu has been a great supporter of Metaviver, and she has received actually 3 grants from us. I think the first one way back in 2013 or 2014 or 2015, it was quite a while ago. So what we're going to do today is get an update on the work that she has done that Metaviver has funded. And I know that your first 2 grants that we awarded you had to do with brain metastases, which is such an understudied area. And until the approval of tucatinib in, God, was that last year in 2020 or late 2019? I mean, every day is Blur's Day, thanks to COVID. But, you know, there were no therapies for brain metastases. And so at least we have 1 now, but we need a heck of a lot more than 1. Because unfortunately, as treatments improve for metastatic breast cancer, we are all more likely to develop brain metastases. We know that about 50% of people with HER2 positive disease will develop brain metastases, about the same number of triple negative, but there's an increasing number of people like me with ER positive disease who are at risk of developing brain metastases as well. So to start off, can you tell us a little bit about the work that you, the initial work that you did, which revolved around kinases? So kinase might sound familiar to some of you because of the CDK4/6 inhibitors, and CDK stands for cyclin-dependent kinase, number 4 and number 6. But can you tell us a little bit about what a kinase is? And I think a lot of the work you did centered around a CDK5. Is that correct?
Right. And the first thank you, Kelly, for the opportunity to get connected and discuss our exciting research tackling brain metastases. And I really appreciate this opportunity. And in terms of what is a kinase, kinase is a kind of an enzyme that put phosphate moiety to another molecule and change to the function of this substrate protein. And in cancer cells, there are these upregulated signaling pathways, mostly are modulated, many of them are modulated by post-translational modification. And one of the major type is increased phosphorylation. And that is why all this increased phosphorylation are induced by increased kinase activity, because kinase put phosphatase on substrate protein. And when substrate protein gets phosphorylated, they are superactive, drive cancer cell, progression. So that is why.
So basically adding a phosphate is like stepping on the gas.
Yes.
Okay.
Your analogy is perfect. So in the past 20, 30 years, there are all these big pharmaceutical companies putting a lot of effort, develop kinase inhibitors to inhibit this function of kinase so that we don't have increased phosphorylation of the substrate protein. And so sort of like using your analogy, put a, brake.
Yeah, putting the brakes on it.
On the signal transduction. And so that's why we have been focusing our study on kinases. And the project funded by Metaviver, actually were based on our labs, I should say, unprecedented effort to search for what are the kinases critical for driving brain metastasis progression. So I had a wonderful graduate student, Frank Lowry. He put in almost 6 years of his golden years life in graduate school, screened the whole human, actually the whole kinome. Kinome stands for all the entire kinase population, and he put each of the kinases into breast cancer cells and to see which one make breast cancer cell become super capable of inducing brain metastasis. And after putting each kinase into cancer cell, then inject this cancer cell individual into mice to test the brain metastasis development in mice population. By that kind of very labor-intensive effort, we identified about the 20 kinases that really drive brain metastasis development. And then we, of course, those are screening efforts. We need to further functional validate that. But with 20 kinases, we need an army to test them, right? And thanks to Metaviver, so we selected one of the top 5 kinases to apply from Metaviver for support to validate its function. And this support was so critical. And so that first kinase is called SPHK1. And we have had a really nice functional validation in human breast cancer cells. If we put that kinase into human breast cancer cell line, then put into mice, induce brain metastasis become very aggressive. Those mice survival will be cut to almost half compared to control groups.
Yeah, and survival, survival as it is, isn't that great with brain metastases? So that, by taking these human cell lines and overexpressing this kinase or make more of this kinase and then putting it into a mouse model, really, is the first step. And a lot of people wonder about, like, why do we have to do all this stuff with cells and mice? Because I don't know about you. I mean, clinical trials, we all need clinical trials, but you don't want some scientists, and I picture, the mad scientist with the crazy white hair. You don't want some mad, some brilliant scientist. I'm not going to call you guys mad scientists, getting this incredible idea and then going, well, let's just try this for the first time in a human. Would you be that human? No, we really have to start. I'm big on analogies. And so I use the analogy for research. It's like a baby. A baby does not come out of the womb and run a marathon.
Right.
First the baby learns to crawl, and then the baby learns to walk, and then the baby learns to run. And so for me, the crawling is the bench research. The walking is the mouse. The walking independently is the translational work, and the running the marathon is the clinical trial. We have to start. We have to start at the beginning.
Kelly, you're absolutely right. And in addition to that, so later when we have drugs, we need to do a clinical trial, to help understand what's going on when the drug get into, live body. So how can we monitor? We cannot, not that we cannot, we definitely, ethically should not do experiments like that in human.
Right.
And also, Kelly, I want to share with you part of the reason I'm so passionate about breast cancer metastasis research. My own mother was diagnosed with breast cancer when she actually was pretty young, 58 years of age, and struggled. She was a physician herself, busy taking care of patients, and she did not do like a annual checkup timely herself because she got so busy. And by the time she felt so tired every day and was diagnosed with breast cancer, she had a surgery. She already had 3 lymph node metastases, stage 2, 3 already, almost stage 3. And then struggled another 10 years with lung metastasis, bone metastasis, liver metastasis. By the end, she had a brain metastasis.
Yeah. And so that's your motivation. That's your why.
Yeah.
And I'm so sorry that you as a daughter had to experience that. But on the other hand, there, you know, and I hate that analogy that, you know, like there's silver linings, but, you know, there was that silver lining that I bet that drove some of this research. Then you were making such a difference in the lives of people currently living with metastatic breast cancer and the people that will come after us. So
Yeah.
thank you so much for the work you're doing, and thank you for sharing that personal story.
So that's why, to me, studying breast cancer metastasis is so important, because we want to, you know, help all these other mothers. And also by definition, I'm a high-risk woman for development of breast cancer myself, for my own population, and also our daughters. So,
right, and our sons too, you know, because
yeah.
you know,
Although they
don't have breast cancer as frequently unless they have some of these germline or inherited mutations. But still, you know, it's going to help. So can you tell us a little bit about where that work that you have done with kinase has gone since, you know, since you were awarded those grants, you know,
so
5-10 years ago?
Okay, for that first one, as I mentioned, we already functionally validated that kinase function. And also I know Metaviral would like to see us obtain additional grant. And I'm very happy to tell you, because the initial support from Metaviral, the clear functional validation, there's a big pharmaceutical company, actually number 2 pharmaceutical company in Japan called Taiho, and they are the one developed EGFR inhibitor, got US FDA approval, you know, used in the clinic. So after they heard and came to MD Anderson, listened to my talk, know our data on SBHK1 supported by Metaviral, so they actually put in quite a sum of money into MD Anderson as a collaboration project. And also the company now is putting in effort develop, they have already developed one SBHK1 kinase inhibitor. And we have tested that kinase inhibitor in our own animal model. Unfortunately, the first generation inhibitor have some effect. You know, we can make the tumor, brain metastasis tumor, smaller, but in terms of instant survival, I told the company they need to optimize, continue work on it. But the first generation inhibitor already being generated. Of course, at this stage, they won't let me talk about, because you know, when you work with a company,
it's all proprietary info. But that's exciting to know that this work, because Metaviver funds early career grants. For those that, you know, for those that are watching that are less familiar with Metaviver, Metaviver funds a couple different types of grants. We fund early career investigator grants for people that are, you know, they've gotten their PhD or their MD PhD or their MD. And they are starting off in doing research, but they're not that far out. They're still relatively junior people, maybe, you know, the first few years of their first faculty appointment. And then we also fund translational grants. Now, back when you first got your grants, our grants were pretty small. The early career grants were $50,000. You know, that's an SUV today. You know, I have a 6-year-old Toyota Highlander that almost cost that much. And our translational grants were $100,000. Now we have since increased our grant amounts. Our early career investigator grants are $100,000 given over 2 years. So basically 50 grand a year. And our translational are $250,000. But it's people like you watching that send the cost of a cup of coffee, or your Facebook birthday fundraisers, or you know, you're doing a garage sale and you're going to give the proceeds to Metaviver. All of that funds this kind of research that Dr. Yu is talking about. So we're so grateful to that. So tell us a little bit more.
So that's the first Metaviver funded project. In summary, we have functional validated, and now pharmaceutical company is developing kinase inhibitor, hopefully we can effectively inhibit this kinase and inhibit brain metastasis, prolong survival. So we'll test in animal model. So that's a continuous collaboration ongoing. Meanwhile, in the lab, I have an outstanding postdoc, Yiming Duan. He is trying to continue to figure out why this kinase, the mechanism, why this kinase promote brain metastasis. And it's going to be a big puzzle, to solve. The reason we want to do that is if we know why, in case the kinase inhibitors have limited efficacy, we might be able to develop additional inhibitor that is, mediating the kinase function. So that was the reason we want to figure out why. So that's ongoing.
Yeah, so that's really exciting. I think we need so much more in the brain metastasis space. And when I hear about these grants dealing with brain mets and the exciting work you're doing, I think it gives a lot of people hope for the future. So I know that you also were awarded a third grant. That's a little bit different.
Actually, Kelly, sorry, my pointer. I would like to report the second grant, the CDK5. So,
yes, please.
So
do.
So the one I was talking about, the first one, which was
the screening, the kind of screening and validation.
5-6 years ago. The second one actually was another top hit from the screening, because I told you we had about 20, and we are focusing on the top 5. So the second one was a grant was funded for another top hit, and we have functional, that's a CDK5. So again, with outstanding postdocs, very strong work. Actually started from the student Frank Lowry. He started all this work, and then another outstanding postdoc, Arsene usually he continued the work after Frank graduated. We have now functionally validated this CDK5 kinase indeed drive brain metastasis very, very aggressively, and also importantly, Arsene has figured out the mechanism. Guess what? This kinase modulates immune response, and it's unpublished yet, so I won't be able to talk about too much detail. But actually, it surprises cytotoxic T cells. Cytotoxic T cell, when they recognize the cancer cell, can kill cancer cell. But when you have this kinase upregulated, the cytotoxic T cell will not be able to effectively see the enemy, will not be able to see the metastatic cancer cell.
So this CDK5, to use another analogy, and for those of you that are Star Trek fans, this CDK5 is like a cloaking device. So it makes it so that these immune cells can't see their target. Is that reasonable?
Yes.
Okay.
Yes.
Thank you.
Yes. I loved your analogy. So Arsene and our team are very, very excited about the funding. So currently we are trying to see how this kinase can, make T cell blind, cannot see it. And so we are trying to find out the detailed mechanism so that we can hopefully reverse the bad consequence of this kinase. And in addition, I'm sure Metaviral will be also very happy to see that with the very little money, seed money we got from Metaviral, we had additional strong preliminary data. We applied for NIH R01 grant, and NIH has funded us to continue this important research so that we can really, continue this journey to identify the mechanism and hopefully develop new, based on the understanding, develop new therapeutic strategies to counteract the effect of this kinase, and with the goal to benefit patients in dire need.
Right. And that, for NIH R01s are a big deal for those of you watching. I mean, and it's so exciting when we at Metaviver hear that the preliminary research that we funded has allowed researchers to get those big NIH grants. Because, unfortunately, one of the things we've learned with COVID is it takes a lot of money to develop something. But we've also learned that with a lot of money and a lot of drive and cooperation, that amazing things can be done. So I am so excited to stay not dead yet for long enough to see the results of your R01 grant work.
Kelly, don't say not dead yet. You live, thrive. You and Metaviver are making a huge impact to the entire metastatic field. And in addition to the funding, the inspiration, I remember several of Metaviver, advocate came to MD Anderson in 2000, actually before pandemic, 2019.
I think it was 18 or 19 that people,
18 or 19, yeah. So, and several of my postdoc had a lunch with, with them, and they are inspired by.
Well, and we were supposed to come. we were supposed to come meet you, a group of Metaviver folks, in early 2020. But hey, COVID. But we are hoping to get our Metaviver C2C RV on the road again in 2022. We hope that enough of the population will be vaccinated, and that we can come and visit labs again and do Facebook Lives while we're there and show people the incredible work that researchers like you do, and the incredible work you do, frankly, in really tiny spaces. I think television shows make everybody think these labs are these massive gleaming places, but often you're doing some pretty incredible work in spaces not much bigger than a walk-in closet.
Yeah, but Kelly, I also want to share good news with you. Yes, I was in the walk-in closet for 14 years. My office had no windows. Okay, it's really it was a closet, changed to my office. I was there 14 years. And the way I told myself is, oh, okay, without any windows, I can concentrate. That's what I mean.
Distractions. We don't want you guys getting distracted, but little sunlight is a good thing.
But now I have to say, I'm very thankful to MD Anderson. My lab had moved to a brand new building, not brand new, much newer building, no more than 10 years old, and with all the big window sunscreen. So when you and your folks, Metaviver friends, come to MD Anderson, you'll be visiting our new building, with all the bright light.
We look forward to that. So super exciting news and an update from you. So we really appreciate it. And I know that COVID threw a monkey wrench into the latest grant that we gave you. Like it threw a monkey wrench into everybody's lives. It really threw a monkey wrench into researchers' lives. So, but can you tell us just briefly what the focus of this latest grant will be when everything's finally back up and running and you're able to get started on it again?
Okay, the latest grant, of course, it's the first year. It was funded May 2020, and at that time the whole lab was shut down. I mean, not just me shut down. The whole MD Anderson, all the research lab was completely shut down, and we had to sacrifice all our mice, whatever. And then we had a partial shutdown, come back. So we start to pick up around September, but I'm very happy to tell you this latest grant was not from kinome screen, but was based on one of my lab's paper published in Nature, and we identified a special tumor suppressor gene is lost in brain metastasis lesion, and when this tumor suppressor gene is called P10 is lost, it changes the whole gene expression profile, and one of those changes is increased secretion of a cytokine called CCL2, and this CCL2 can attract CCL2 receptor positive myeloid cells. That's called CCR2 positive myeloid cell.
So, so I'm going to interrupt you for 1 second. Can you tell
Sure.
people what a cytokine is? And
okay.
Start with that. Start with what a cytokine is, and then a myeloid cell is part of the immune system. So
yeah, right. Cytokine is the kind of a protein factor secreted by cells that can how can I say, attract, can bind to its receptors and induce various functions in the cells expressing the receptor, including, sometimes make those cells highly proliferative or more motile. They can travel attracted by the cytokine, and many cytokines induce, say, inflammation response, things like that. So it's kind of a small protein factors secreted by cells and mediating communication between one cell with another. And so
it's kind of like wearing perfume to attract a mate.
Good analogy. And so this work was actually led by an outstanding postdoc in my lab, Dr. Lin Jiang. And after she found this cytokine can attract CCR2 positive myeloid cells, she tested what these myeloid cells do to cancers, metastatic cancer cell. And unfortunately, she found that these myeloid cells help metastatic cancer cell proliferate and also protect metastatic cancer cell from apoptotic cell death. So this metastatic cancer cell can thrive and outgrow in the brain, become symptomatic metastatic cancer cell, induce all the bad consequences. So based on that finding from her, we applied to Metaviver. We want to test if we block this myeloid cell function, can we inhibit brain metastasis? So that's the whole, hypothesis we are testing with this Metaviver support, and it's ongoing right now.
Right. Yeah, because again, everything was delayed. So to explain to the audience, when we award a grant in 2019, the recipients of our grant don't receive the money until 2020. So the work starts basically the year after the grant. And our grants are currently all 2-year grants. So I look forward to taking a trip to Houston in about 2024 and sitting down with you over a cup of coffee in real life and getting and with your postdocs and getting an update on this latest grant. So we at Metaviver are so excited about playing a small part in the work that you do, because I think your work is just brilliant and it's so exciting. And I'm so grateful to researchers like you and like the students in your lab, because, one of the other things I think is really important is that research is hard. And, you get that person that makes, that finds something that turns into, a huge profitable discovery. And that, that one person can get, kind of rich, or that institution. And it's more the institution. but research is hard and there's not a lot of money in it. And we're competing for, you know, research dollars with, you know, the Department of Defense and bombs and tanks and things like that. And one of the things that we're really proud of at Metaviver, and I think personally is so important, is our young career investigator grants, so that we can keep people that have an excitement about science and are interested in studying metastatic breast cancer, that we can keep them in that field. Because if there isn't this kind of seed money, they're going to go find something else to do that's going to make their family life more stable and better for their family. So again, people watching, you know, go to metaviver.org and click on that donate button so we can keep funding Dr. Yu and the postdocs that are coming out of her lab and other labs across this country, because research is where our hope lies. You know, we need research, not ribbons, is one of the things that I always say. And again, I am so incredibly grateful to you. Before we end, is there anything else that you would like to mention?
Well, I do want to mention that it takes the whole village to succeed in conquering cancer metastasis. And Metaviver's effort is so critical, and especially all the Metaviver is funded by breast cancer, you know, advocates. And as I shared with you, my own mother died of breast cancer metastasis, and she was a doctor, but I know the 10-year fight with breast cancer, it was a very challenging journey. And imagine Metaviver advocates, they have to cope with, you guys have to cope with your own disease and have to monitor disease recurrence. Meanwhile, working so hard, raise money, penny by penny, dollar by dollar, to invest in metastasis research and in future generation of younger scientists, so that we can eventually succeed in fighting this battle. So I really want to take this opportunity from the bottom of my heart, our gratitude for your incredible effort. You know, this is high impact work. It's beyond the measure. It's something you cannot just measure by, say, the dollar amount. It's beyond the measure. So from the scientist part side, we greatly appreciate you and the whole Metaviver Foundation's hard work to make a difference. And from our side, it inspires us to work hard. Every dollar counts. I actually tell my trainees, you know, we need to really make a difference to, you know, feel we are not letting you guys down. You know, we work together with you to make an impact, and which I believe will benefit millions and millions of cancer patients, our own generation, and our future generation as well.
Yeah. Again, thank you. Thank you for your time today, and thank you for the work you have done and that you continue to do. And again, we look forward to sitting down with you in person, hopefully next year in 2022.
Yeah, when you have a chance to come to MD Anderson, we should, you know, really have I hope by that time we are allowed to have a real hug.
Right, yeah. But for now, it's a virtual hug. So,
and also we sort of just have the elbow touch each other now.
Right, yeah. We're all looking forward to real hugs.
Same
so
here.
Thank you again so much for your time. I appreciate it.
Thank you, Kelly.
So much.